India. The emerging in defense manufacturing, empowering our armed forces in the high mountains, fighting battles in the harsh terrain of deserts, and securing India's vast coastline. The emerging Indian defense industry is marching ahead with strength, power, continuously engraving the success story of Make in India. A well-developed ecosystem has created indigenous capabilities in naval systems, aero systems, missile, electronics and land systems, keeping pace with the global trends in war-fighting technologies. Greater emphasis on self-reliance, increased participation of the Indian industry with startups, MSMEs, ordnance factories and PSUs as partners. A robust defense and aerospace industry base has been created by simplification of procedures, new policy for indigenization, innovations for defense excellence, offering government test facilities and proof ranges to industry, dedicated team to facilitate the private industry, encouraging intellectual property culture in defense, defense corridors in Uttar Pradesh and Tamil Nadu, reforms in offset policy. Such initiatives have strengthened the ecosystem and defense manufacturing base of the country, resulting in growing investments, production and exports. And the journey of excellence continues. After the remarkable success of DefExpo 18, Ministry of Defense is ready to showcase the digital transformation of defense at Lucknow, a vibrant manufacturing hub of Uttar Pradesh, focusing on innovation and emerging technologies, bringing in a paradigm shift from conventional to futuristic technologies. A show of India's renewed and strengthened defense and aerospace industry, showing alongside the experience of global defense manufacturers. Come, experience the power of growth and commitment. DefExpo 2020. Explore the world of opportunities.
Hello, good afternoon, namaste. A very warm welcome to yet another webinar for Defense Expo 2020. My name is Bhumika and I welcome you all on behalf of National E-Governance Division LMS team. These webinars are a collaborative effort of Department of Defense Production, Ministry of Defense, NEGT Digital India LMS team, Ministry of Electronics and IT. As India is emerging as a defense manufacturing hub, this edition of Defense Expo is focused on digital transformation in aerospace and defense sector. DefExpo 2020 will bring the leading technologies in the defense sector under one roof and provide a myriad of opportunities for government, private manufacturers, and startups. The event is scheduled from 5th to 8th February 2020 at Lucknow, UP, India. Those who have been with us in our journey, they have heard a lot from our eminent speakers. In case you're joining us for the first time, I welcome you and request you to stay connected for our next webinars as well. Today is the second last webinar for the series of Defense Expo 2020. Today, it is my pleasure to welcome Dr.Kota Harinarayana. He is a SERB Distinguished Fellow, Honorary Advisor at CSIR-NAL and Chairman General Aeronautics Private Limited. He was conferred the honor of Padma Shri in 2002 and is joining us from Bangalore, HAL. He would speak on the topic From Manned Fighters to Unmanned Combat Aircraft, the Evolution. Also joining us is Colonel Anil Gupta from Department of Defense Production from NEGT Studios here at New Delhi. He would give us an overview of the topic and our speaker for today. Before I hand over, I will take you through certain housekeeping rules. As you see on the screen, this webinar would be approximately for 1 hour and would conclude at around 4 p.m. Indian Standard Time. I would request all the panelists to disable their microphones and cameras when not in use. There is a chat option for our users, and please share your concerns and feedback on any audio-video problems you are facing through this chat option. There is also a Q&A section. Please put your questions in the Q&A. Our speaker would be happy to take the questions at the end. For the last webinar, Mr. Subhabrata Mitra from Ratnabali Group is the winner. For today's webinar as well, we'll announce the winner for the best question in our upcoming webinar. There is a poll at the end. I will request all our viewers to please rate us in the poll for the quality of the webinar. There is also live YouTube streaming happening for this webinar. We'll share the link shortly in the chat section. With this, now I hand over to Colonel Anil Gupta to introduce our topic and speaker for today. Over to you, sir.
Thank you, Bhumika. We are indeed privileged to have among us Dr.Kota Harinarayana, a highly qualified and distinguished person. Dr.Kota Harinarayana was born in Berhampur, Orissa in 1943. He graduated from Banaras Hindu University in Mechanical Engineering. He did his post-graduation in Aero Engineering at IISc Bangalore and his PhD at IIT Mumbai. In addition, he holds a bachelor's degree in law. He started his career at Hindustan Aeronautics Limited in 1967. He moved to DRDO headquarters in 1970 and held various positions till 1982. He rejoined HAL in 1982 as chief designer in Nasik division. He was deputed to DRDO in 1985 and assumed charge as Director AD Bangalore. He was appointed as Light Combat Aircraft Program Director in December 1985. During 1995, he was elevated as Distinguished Scientist by DRDO. As Program Director and Chief Designer of Light Combat Aircraft, he successfully directed the project leading to flight testing and clearance for limited series production. Thanks to his efforts, India succeeded in developing a state-of-art high-technology fighter aircraft of world class. He is the Fellow of Aeronautical Society of India, Indian National Academy of Sciences, and Indian National Academy of Engineering. He received Distinguished Alumnus Award from Indian Institute of Science, Bangalore, and from IIT Mumbai. He was awarded National Aeronautics Prize and FIE Foundation Award in 1996. He received SBI Pragna Puruskar in 2001. He received the Dr. Y. Nayudama Memorial Award and the DRDO Technology Leadership Award for year 2001. He was honored with Padma Shri by Government of India in 2002. He received Gujarmal Modi Science Foundation Award for the year 2006. Indian National Academy of Engineering conferred upon him the Lifetime Contribution Award in Engineering for the year 2006. He was awarded Shri Om Prakash Bhasin Award for Science and Technology for the year 2007 in the field of engineering, including energy and aerospace. He also received DRDO Lifetime Achievement Award in 2008. He was conferred with honorary doctorates by Berhampur University in 2008, by Acharya Nagarjuna University in 2012, by SOA Bhubaneswar in 2013, and from Ravenshaw University, Qatar in 2017. He received Lokmanya Tilak Puruskar in 2011. He is also recipient of Aryabhat Award for the year 2014 from Astronautical Society of India. He was formerly Vice Chancellor of History of Hyderabad till 15th July 2005. He was also Chairman of Research Councils of CSIO Chandigarh and Center for Wind Energy Technology, CWET. He is nominated Director at Midani. He is also Distinguished Visiting Professor at IIT Mumbai, Pratt and Whitney Chair Professor at University of Hyderabad, member of UGC Empowered Committee on Basic Research in Science, Dr. D.S. Kothari, DRDO Chair at ADA Bangalore, INAE Satish Dhawan Chair Professor at CSIR-NAL. He is also Chairman, Board of Governors of IIIT DM Jabalpur. He is at present SERB Distinguished Fellow, Honorary Advisor at CSIR-NAL, and Chairman, General Aeronautics Private Limited. Today, he would be giving a talk on from manned fighters to unmanned combat aircraft devaluation. Well, in the Second World War and subsequent wars, fighter aircrafts have played increasingly vital roles in the outcome of battles and wars. In fact, no country which has gained air superiority ever lost a war. The talk will cover the roles of fighters and evaluation of fighters in the versatile machines with all-weather day and night capability, with precision weapons, sensors, stealth, and a host of other features. The talk will also cover the developments done in India and future programs that will provide India with total indigenous capability to achieve air superiority. Without taking any more time, let me hand over to Dr. Kota Harinarayana from Bangalore. Over to you, sir.
Thank you. Good afternoon to all the participants and the participants in the webinar. And I'm happy to share with you my perspective on the role of fighter aircraft, how India is doing, where we are now, and what will be the future, and how by developing these technologies, we'll reach a stage where we'll be considered as a major power in the world. So let me start. Here is the topic which was already introduced to you. Here is the scope of my presentation. What is the importance of air power? How it has evolved over the years. One major program we have taken in India is the light combat aircraft, Tejas. There are variants of LCA which have been developed and being developed. What is India thinking beyond the light combat aircraft? Two things I thought I will talk to you, the 5th generation fighter and the 6th generation unmanned combat air vehicle. What are the roles of technologies and processes and practices? It's very important as we move forward. And a few remarks, I'll be ending my talk. Let me proceed further. I thought I will start with this particular quotation from Winston Churchill, which he made in 1933. Not to have an adequate air force in the present state of war is to compromise the foundation of the national freedom and independence. This is what he said in 1933. What he said in 1933 is more important, more relevant today, and it will be so for decades to come. So that is the kind of thing. In fact, there is no country which had an air superiority has ever lost a war. That is the importance of this. Let's also look at how we are proceeding further. When we talk of first generation, second generation, third generation, fourth generation, fifth generation, we are all talking about after the Second World War. The first generation aircraft are basically jet aircraft, jet fighters, in fact. They are the subsonic aircraft, they are guns, bombs, rockets, and they are between 1945 to 1955. Then the second generation came. They are supersonic aircraft. They had radar, very first generation, very, very rudimentary radar, but their onboard radar was there. New missiles have started coming, and we are integrated those. The designers have integrated the first generation missiles, and guns continue to be there. That is the second generation. Some of the participants here may remember that India had developed an aircraft called HF-24 developed by Hindustan Aeronautics Limited. It was basically a first generation plus. The subsonic aircraft, it had guns, it had bombs, it had rockets, and large number of aircraft were produced. But then the second generation, we have not done anything. Third generation, we have not done anything. And when we started the light combat aircraft, there was a need to develop a fourth generation fighter. The key features of a fourth generation fighter are low observable treatments, very advanced avionics, guided weapons, and agility, speed, maneuverability. These are the kind of things. And India started the developmental work, and I would be talking a little bit about this, what we have done, what we have achieved. The next generation is the fifth generation fighter, where the key feature is advanced stealth, good performance, payload is internally carried, then information fusion takes place. It is a net-centric operation. Fourth and fifth generation fighters become net-centric, sustainable, deployable, and total air dominance is the characteristic of this particular era. So let me now go to the little bit detail about the light combat aircraft, a fourth plus generation fighter which India had developed. Before I talk about it, let us see what are the key characteristics of these generations of fighters. We started with a single role, the first generation and all, that means either day fighter. They're basically day fighters. Then we talked about multi-role, day and night. And today we talk about all-weather operation. A very important all-weather, day and night, any environment, the fighter must be capable of fighting. And that is today's scenario. Then we talk about the weapon lethalities. We're talking bullets and gravity weapon. That is how it started, the first generation, even to extend second generation. Then missiles became the backbone of the fighters. And the missile continued to play a dominant role. Now we have what you call the precision weapons. Air to ground, very high precision weapons, pinpoint accuracy, you are able to get now. This is the latest generation, what you call lethality that we have achieved. Then survivability. The survivability is the key thing. Aerodynamics was the first, second generation, where improved aerodynamics allowed you high performance, high maneuverability, high range and all. Then electronic warfare came. The electronic warfare, active jamming, passive, what you call electronic warfare technologies. The aircraft was able to survive and able to, what you call, do damage to the adversary. Now we are talking stealth at the survivability, key survivability characteristics. Now, the next and an important thing is interoperability. Earlier, they were all individual aircraft flying on their own. Then came the collision warfare. And now we are talking about joint and collision integrated warfare. Okay, this is what is the present generation. All the armed forces are working towards this one, and all aircraft that are now being developed in India. This is the direction where we are moving. Now let me talk to you the next about the light combat aircraft. This is the air superiority fighter for India in the 21st century. Very lethal, very high precision. Air-to-air and air-to-surface missiles, accurate nav attack system, and all the general systems are there. Survivable, extreme, very, perhaps the smallest fighter, supersonic fighter of its class in the whole world. Very reduced signatures and integrated avionics are the key features. It is versatile, it's a true all-weather aircraft, multi-role, day and night. And this aircraft was designed whereby it is highly maintainable, supportable, and its MTB of mean time between failures is twice, and it has online health monitoring, and man-hours required, maintenance man-hours is half that of a standard aircraft which we have in Indian Air Force. A really world-class 4+ generation fighter, and to achieve this kind of requirement, very advanced technologies were required. These are the salient features. It's a tail delta compound suite, a unique aircraft of this class in the world. It has a high degree of static instability, unprecedented for a tailless aircraft of this class, 200 milliseconds, time to double amplitude. It has a quadruplex redundant fly-by-wire system, all digital fly-by-wire system, all composite airframe, perhaps highest percentage composites of its class in the whole world, has all glass cockpit and microprocessor utility systems, enabling what you call online health monitoring, and fixed geometry, simplicity, survivability. That is what they feature here, and very low wing loading that enables very high maneuverability and point performance. The single GE404 engine, very reliable, rugged engine, which has given the high thrust to weight ratio to this aircraft. These are the key technologies. I will not go too much in detail, but I want to mention to you, very high performance engine. I talked about it. It has a dual redundant utility management systems, a 0-0 ejection seat, very advanced digital avionics, multi-mode radar, advanced cockpit, unstable configuration. It needed a very advanced fly-by-wire system, very advanced materials, composites, aluminum lithium alloys, and many other alloys that are required, and very advanced next generation systems, stealth, very small aircraft, built-in stealth, many stealth features, and a quadruplex digital fly-by-wire system. All these technologies have been developed, and they together give a formidable performance and survivable and maneuverable capability to this aircraft. Reliability of this aircraft has been built in from design stage. Perhaps the only aircraft in the whole world who never had any serious accident or incident throughout its last 20 years, and it shows the robustness of its design. And last few years, its operation in the fleet has demonstrated its high reliable features. It also has demonstrated its high maintainability features, built-in maintainable characteristics, so that the turnaround time could be brought down, and it is a boon to this aircraft, and a unique aircraft with this kind of reliability and maintainability characteristics. One of the unique characteristics of this aircraft is the high percentage of composites. 90% of the aircraft is having advanced carbon composites, and 45% by weight in the composites. Of this class of fighters, perhaps this is the highest percentage of composite in the world today. One of the key features of this aircraft is quadruplex digital fly-by-wire system. It's an all-digital system without any backup, and it has proved itself abundantly well in the last 2 decades of operation, and the safety features have been built in so that the carefree maneuvering has been demonstrated, and that is what gives that edge to this aircraft compared to other aircraft of its class. The integrated flight control system, all the systems, most of them have been now indigenous. As a result, we have a critical technology. We have a total hold over this capability. A digital avionics and weapon system is all digital cockpit, very advanced features, and designed keeping the Indian pilot in view. So the pilots feel very happy to fly this aircraft, excellent handling qualities, and that makes this aircraft a unique aircraft of this class in the world. This is how the glass cockpit looks. The avionics is the backbone for the mission systems. Most of the systems are indigenous, and 1 or 2 which are imported, they are also in the process of getting indigenous. So you could see that the indigenous content of this aircraft is extremely high. I'll show you a few more slides which will show how indigenous this aircraft is. Here is the environmental control system. The key elements of this, the heat exchangers, the cold air unit, all other elements that go in it are all indigenous. And the system has proved itself so well. Today it is considered one of the most comfortable aircraft for the pilot to fly. And it keeps the equipment temperatures low enough, thereby the reliability could be increased quite substantially. Here is the hydraulic system. Again, the gearbox, the secondary fuel system, the jet fuel system, all of them have been developed. And the landing gear has been initially done by colleagues in Hindustan Aeronautics Limited, and many other components have been done within the country. So the indigenous content of this system is pretty high. They have the secondary power system, consists of the gearbox and the jet fuel starter. Both have been done indigenously, and the PTO shaft also has been done indigenously. And it's the lifeline link between the engine and the aircraft. And this has performed itself exceptionally well and proved its ruggedness, reliability, and maintainability quite well. Here is the brake management system and nose wheel selection system. It is a brake-by-wire system, and the system has now come to a very high mature level and has now performing exceptionally well. The whole system, all the systems here are indigenous now. One of the last things that was added recently, a couple of years back, for the air-to-air refueling, and this is what increases the range, increases the reach of this very, very small and light aircraft. This has proved itself quite well, and now all the aircrafts are now getting integrated with this air-to-air refueling system. This is the little bit more in detail about the air-to-air refueling system, and it has proved itself pretty well, and the results are quite good. Now let us see a little bit about the enabling technologies which enable such a high technology aircraft to be developed in the country. Let's have a look at it. When we started the project, we had no CAD, and today we have a digital product line, extremely highly developed system. Total things is digital. Whole development is taking place digital without any manual intervention. And that is what has happened in one single project. That is what the result or benefit of this project. The key things we developed was the development of composites, how to design, how to manufacture, how to inspect. From end to end, the software has been developed and was developed essentially for the light combat aircraft, but subsequently this software bought by companies like Airbus, Boeing, Russians, and many other companies. And at one stage, the software proved it was considered the best software available anywhere in the world. And this certainly has helped in designing a really lightweight fighter like light combat aircraft. One of the key features, key important features was the fly-by-wire system and the controllers. The 6 degree of freedom simulation was a key requirement to develop these controllers, develop the handling qualities, and make this aircraft a versatile aircraft with excellent flying quality. And this is the technology, the light controller, how we synthesize and use this facility. It is a very important technology that has come out of this particular project. The software, this aircraft is fully, it is more like a cyber physical system, more software than hardware, and millions of lines of code. And the technology of validation verification, development, validation verification, reached a level of maturity where we never had any problem of software failing throughout the last 2 decades of aircraft operation. This itself is a major technology that we have developed in this project. Very important critical test facilities have been created. For example, we have a lightning test facility where the complete aircraft can get inside and we can simulate the lightning of billions of voltages, billions of current while the aircraft is in operation. A unique facility of its kind anywhere in the world, and it has proved itself quite well. I have the brake management system, many other fuel rigs, many other rigs, dynamometer facilities, iron bird, secondary power system rig, undercarriage testing. In fact, lots of such facilities which are developed have come to the rescue of the aircraft and enabled aircraft development and making the aircraft really robust, reliable, and maintainable. I think these test facilities have become the backbone for the development, and now they are the backbone for production and in-service operation. The end of the day, the whole aircraft had to be flight tested. So a lot of unique technologies have been developed as a part of our development program. And the flight test program has enabled this aircraft to come to a very mature level. And today, this aircraft, thanks to very intense and extensive flight testing and flight test technology that has been developed, keeping in view the risk levels, proved itself well, and we were able to do the development with almost no what you call serious incident or accident. It goes to prove the kind of technologies that have been developed through this project. This is one project where we networked the whole country. It gives you a rough idea about how every part of the country has participated. They continue to participate, and we are, these are the partners we look forward to their participating in our subsequent programs. I thought I will show this particular slide because it is very, very important when you do a very, very complex program. One is the knowledge generation, normally done by design teams, R&D labs, academia, and industry. Then this knowledge has to be what you call intensified. It is done normally at our what you call sister organization, Aeronautics Limited, our system labs, CADA, ADE, etc. Then this whole thing has to be validated. The certification agencies, that is SEBILAC, Indian Air Force, National Flight Test Center, they go through this validation exercise. At the end of it, the whole knowledge needs to be transferred to the production agency, which is the production divisions of Hindustan Aeronautics Limited. So this is the light combat aircraft knowledge circle. It is important to see that for a successful program, we pay attention to all the four wings, all the four elements. And only when we complete all the four, then we can say the project has fully succeeded and it has really delivered the results which we were looking forward to. And that is what has happened. Now the production system has now gone into the groove and things are happening. And we are looking forward to more and more aircraft being produced, and more squadrons are going to be equipped with India's light combat aircraft Tejas. This is what I consider is what came out of this. The goal, mission was to make a light combat aircraft. Ideas were generated, skills and facilities were created, technologies were developed, systems came out of that technology. Then more than anything else, a culture has been developed where the team knew that how to develop a complex system, very advanced technologies, how to make it reliable, maintainable, producible, and how to establish the nationwide capabilities whereby not only this aircraft could be produced, and it laid the foundation for subsequent aircraft which are on the anvil now. This is an important outcome of this particular program. The support system for innovation and knowledge generation is a very, very crucial outcome of this program. Now let me talk to you a little bit about what are the variants of light combat aircraft Tejas. One is the trainer, another is a naval aircraft, a very unique capability that has been generated. Recently, this aircraft achieved a remarkable feat of landing on Vikramaditya. This is the way the configuration has been changed, Air Force fighter to Air Force trainer, then naval variant, see, similar but some change. Again, next, similar but some change. There is one unique device called LEVCON, leading edge vortex controller, has been introduced, possibly the only aircraft in the whole world which has this kind of capability, this kind of device. And this is what came out of our in-depth studies, and that's how we graduated from an Air Force variant to the naval variant. These are the requirement, ramp takeoff and landing on a carrier. This is what the naval aircraft was required to be done. It has been done. This is the key features of the LCA Navy, and you could see characteristic feature of leading edge vortex controller, a unique thing of this class of aircraft. These are the controls. These are the other things. You could see that. Very advanced facilities have been created at Goa. And these are the facilities which came to the rescue of testing the whole aircraft, developing the technologies, proving the technologies, and maturing the technologies. After all this has been done, now the trials have been done on the Vikramaditya. This is where the light combat aircraft Tejas naval variant taking off from the ramp. And the next one shows you the aircraft landing. Recently it has been done. Not many countries in the world have this capability. It's a unique capability developed in the country, and certainly a capability that will come to our rescue for years to come. Let me now talk about the future. What I have talked so far are the existing programs. The medium weight fighter, advanced medium range combat aircraft called AMCA, and very much in future with unmanned combat aircraft. Let me talk a little bit of each, and let me also talk about what are the technological trends that are occurring in the world today for this class. This is the medium range fighter, initially talked about as say Mark II, but it is now a fighter with advanced, very high payload capability, as I will show you in the next slide. You could see that LCA Mark 1, Mark 1A, it has a G404 engine, 13,500 kilograms all of weight, and a payload about 3,500. Let's say Mark II, initially the study was just to increase the payload, but today what has come out is a new engine, a derivative of 414. But look at that, it is capable, it's 17,500 kilogram all of weight with a payload of 6,500 kilograms, almost double the payload. With this kind of capability, this aircraft is now can replace the medium weight class of aircraft like Mirage 2000, MiG-29, and Jaguar. So a lot of aircraft this single fellow can replace. So very important development now on the anvil. And this is what is going to replace large number of aircraft of Indian Air Force. Now let me talk a little bit about 5th generation fighter, AMCA, a very important fighter with stealth characteristics, with net-centric warfare capability. And these are the key features of this 5th generation fighter. It has an electronic scanning radar, very advanced technology, with a PVI cockpit, with a pilot vehicle interface, a serpentine air duct, then integrated flight and propulsion system, an internal weapon bay, and the structure itself is radar absorbing structure. Not only radar absorbing, but high impact strength. These are the key features. Let's look at a little more in depth. If you look at the stealth materials and all, we have skins, we have joints, gap. All these are important. Radar absorbing structure, radar absorbing paint. Then FSS radar is a very unique radar. The canopy has an indium tin oxide coating. The leading edges are made of radar absorbing structure. High temperature alloys are used, and trailing edges are also made of radar absorbing structure. And nozzle high temperature thermal barrier coatings. Happy to tell you, most of these technologies are already developed, and they are in advanced stage, and they are ready getting ready to be incorporated in this 5th generation fighter. This is the serpentine intake, a very important feature of a 5th generation fighter, whereby you reduce the radar cross section that normally will be there. Intake is straight. This is the internal and external carriage. In its stealth configuration, no external stores are carried, only internal weapons. Both bombs and missiles are carried. But when in non-stealth configuration, can carry bombs, missiles, and rocket pods, and drop tanks, and many other things. Okay, that is what this configuration is. So today, the LCA Mark 1 is has entered into service. Mark 1 is on the manufacturing line, and Mark 2 is now in the final stages of design and getting ready from next month into metal cutting. Then the AMCA Mark 1, AMCA Mark 2. In fact, when all these systems are ready and they enter into service, virtually Indian Air Force will have only indigenous aircraft, from 100% imported fighters to 100% indigenous fighters, and that is what possible next 15 to 20 years, and that is what we are all working to see that it happens. I want to talk about this particular thing, AVAX. It's an experimental program done long time back. This aircraft had an accident, but gave valuable inputs. With that input, this is the aircraft that has been developed by colleagues at CAPS of DRDO, and this has now entered into service, and very advanced features, and a very, very light and agile platform. with in-flight refueling, efficient multi-role systems, and it has an additional APU. And with all these capabilities, it is now becoming a very important part of India's offensive and defensive capabilities. That gives you an understanding of how this aircraft with the same platform, how Indian system fares compared to other. You could see that the India's AWNC, which is on the same EMB 145, and much better features and better capabilities compared to Sweden, Brazil, Greece, and Mexico. So it is certainly the front-end aircraft that has come out of the DRDO and the CAPS. Now let us look at that. One of the key things that has come out here is we're crossed over to ISAR technology. India is one of the very few countries who have this ISAR technology, and this technology is now getting into LCA Mark 1A also. So this is an important technology that has been developed in the country. So this is what, with this aircraft now in operation, it is able to now, what you call, becoming the eye in the sky, and tremendous amount of what you call strength is being given to the Indian Air Force, Indian Armed Forces by its presence. Now, thanks to success of this program, two other programs are now being done at the end. One is the multi-mission maritime aircraft, other is AWACS with 360 degrees capability. The previous one had some blind spots in front and rear, whereas this will have 360 degrees capability. They are under development, and I'm sure they are entering into service pretty soon. Now let us see the sixth generation fighter. It's an unmanned combat aircraft. Many countries in the world are working. India also is doing work in this area. Let's see what are the challenges of this particular aircraft. This is something like a flying wing, and the whole thing, stealth is a key characteristics, and internal weapon carriage is also a key characteristic. These are some of the technologies. I have taken the slide from DARPA, and you can see some of the challenging technologies that need to be developed, need to be integrated into the aircraft to make it a success. And these are the technologies which are now on the anvil at many work centers in the country. This gives you an idea about what is the level of autonomy we need to achieve to come to what you call a sixth generation unmanned combat aircraft. We are somewhere around 4 to 5. We have to go up between from 8 to 10. That is what now is challenge, and the challenge for the academic institution, R&D laboratories, and industries and startups. That is what is now the challenge that is there, and we need to work towards achieving these goals. Everywhere in the world, this is the challenge which is now being tackled. Let us spend a little time on the effects of autonomy. Autonomy system improve productivity. They can operate continuously. They can increase information sharing. They can process tremendous volume of data. They will work where we cannot safely go. Lot of benefits. That's why autonomy in air, autonomy on ground, autonomy in sea, all that is going on. But let's look at what are the side problems that will occur. Let us look at it. Autonomy also creates other issues, emergent behavior, continuous change. Human-machine interface is a challenge here. How to do validation verification? There is no human being to report to you about the problem. How do you do that? How to trust such an autonomous vehicle? How do you handle attack vulnerabilities? And there is a worry that if you have so many autonomous systems, there will be unemployment. How do you tackle that? How are you handling unintended changes to other businesses? And there is a problem of ethics. And issues from new interfaces and information world. Tremendous amount of information. How do you handle this? These are the challenges that need to be tackled while we are taking the benefit of autonomy. But this is something we must do, because the sixth generation, what you call unmanned combat aircraft, has to be done. These technologies are vital for us, and we must master these technologies. I just thought I will show a few slides, which in course I have shown in their presentations. Increasing complexity of systems. You see, last 10 years, the number of functions have galloped. You see the gradient, extraordinarily steep gradient, compared to what happened in the last 90 years. You can see so many new functions. That is because of the digital environment we have created. So how do you handle this? Now let's see what it means. It also means not only new functions, but at a cost which is much, much, much lower. I just got this from Inco's presentation. Cray 1 was developed in 1976. It was costing 9 million at that time. Okay, iPhone today, okay, it had 1,000 times more capability than the Cray 1. Okay, if the same old technology levels were to be used, this iPhone would cost about $3.2 billion. But today we know how much it costs, a few $100s. See the kind of thing. Complexity increasing, but cost reduction, extraordinary reduction in cost. This is the thing. These are the challenges. These are the opportunities. Also, another big important thing is technology adoption. If you can see that when we made a car, when there was a phone, when there was electricity, there was TV. Okay, car took about 40-50 years to come into the mainline. Similarly, phone took, electricity took time, TV took time. But now you see the mobile phone. In a matter of 5 to 6 years, from being, it has become to a level where it has invaded the whole world. That is the speed at which technology is now getting absorbed, adapted. So time becomes cost becomes an issue. These are the issues that we are facing. So what are the things? From a stovepipe model and data sources, the digital engineering is becoming an ecosystem, a digital engineering ecosystem. Okay, and we need to consider modeling a cut system so that interact in a system of systems and mind. This is what is important for us. This is a critical thing which we see for current to the future, and this is an important feature for us. See the challenges of digital engineering. We have to transform the practice, the data and artifacts, the integration, the response to change. These are the key issues I've listed here. I don't want to go in detail, but these are the important things that need to be taken into account as we are moving into digital world and more digital world. Third, next one, from standalone to interconnected to IoT. You can see the interconnection to IoT, Internet of Things, from supply chain to physical world web. All those millions and millions of sensors are all getting integrated. Our whole world is getting integrated. With the cloud, it is helping us to do. But this again throws further challenges. Security is a major issue. Data has to be considered as a valuable source. Regulation standards are not yet there. And life cycle sustainment is a major challenge. All this needs to be there. It applies to IoT, smart, anything, and other high interconnected systems. These are the challenges which need to be tackled. And once you address these issues, making the 6th generation, 5th gen fighter becomes an achievable thing, and it also becomes affordable, and life cycle issues can be addressed. These are the kind of various technologies that have been there, and these technologies now, when you integrate them, you come to Industry 4.0, and Industry 4.0 to the future factory. I just want to show you this. All of you, many of you are familiar from first industrial revolution to second industrial revolution where electricity came, third industrial revolution when electronics came. Now we are in the post-industrial revolution where cyber physical system, Internet of Things, sensor networks, big data, I will give a list, artificial intelligence and autonomy. These are the things which are the present 4th generation challenges and opportunities. So I want to make this last slide. We have to change the practices. We have to have the collaborative engineering, complex systems understanding, system of systems engineering, system architecting for multiple viewpoints, composite design, design for resilience, design for security, system for integrity, decision support system, virtual engineering using MBSC, part of the digital revolution, change of process implementation, address technology and application, and tailoring and scaling practices. These are the practices which are important, vital. We must understand them, master them, and when you introduce these practices, the new digital world, we will be able to conquer. The 6th generation unmanned combat aircraft will become a reality at a cost which is affordable. So thank you very much. Thank you, and I'll be happy to answer any questions.
Thank you, Dr. Kota Harinarayana, for such an educative and detailed talk. Now it is time for questions. We have indeed some very interesting questions as well. I would request the team at Bangalore to help sir with some questions on the screen, please.
Your first question is, why can't Astra missile can be used in UAVs? Yes, it can be used in UAVs. You need a bigger UAV, not a small UAV. When the UAV is big enough, certainly Astra missile can be used. In fact, unmanned combat aircraft will use air-to-air missile. That is one of the features of an unmanned combat aircraft. That's what a combat aircraft is supposed to do. Certainly possible. What is the potential using UAV for LOT-based cognitive systems? What is the potential of using I thought UAV is one of the means and one of the beneficiaries, both ways, okay, of this kind of technology what we are now talking about. Are there any model of UAV, especially designed modified for rescue and firefighting activities? In India, we have some aircraft. There are what you call startups like at Institute of Science, General Aeronautics. They have made very big what you call vehicles which can carry. When we scale them up, they will be able to do. They are all something like hexacopters with redundancy, with survivability. Even if there is a couple of those propulsion systems are failed, it can still survive and it can do that. The design is now going through various tests. I do believe it can be scaled up to do firefighting and similar such activities. What is the potential of conversion also into UCAV? What would be the time frame for India for conversion? In fact, an unmanned light combat aircraft is we need to do that. I think a lot of studies were done. I myself have done some study about 3-4 years back, and what we call it as what you call not only unmanned light combat aircraft, it can also what you call a pilot can sit there in case initial stage of development and until the maturity level comes, then you can pilot need not be there. But if all the work that is required for us to achieve that has been done, and it is possible. And I am looking forward to such a thing happening. Which tool is used to prove that where we stand in development of stealth technology? I showed you a few slides. Okay, those slides have come out about what are the kind of things that are happening in the country. What is the development program indigenous engine for LCA and UCAV? Let me talk to you about UCAV. The UCAV engine is a fairly advanced stage, and the light combat aircraft, they're still working on that. It's still work in progress. I hope the AMCA will have our indigenous engine. What is the development status of twin engine LCA? No, it's not a twin engine LCA. Light combat aircraft will continue to be a single engine, but the AMCA, advanced medium combat aircraft, range combat, it will be a twin engine aircraft. The Mark 1 will have a G414, but the Mark 2 will have an advanced engine. In Tejas and AMCA, ISR radar, avionics, engine, missile will be domestic or imported. As the ISR radar is already under testing on one of the LCA platforms, and so avionics are already indigenous, and so all the things what you are talking would be indigenous. Okay, how to make a quadrocopter resilient to severe weather condition? That's what I feel. Just a quadrocopter cannot be resilient. You need to have at least a hexacopter, so that if your one engine fails, second engine fails, you can still be able to fly. And the controller development is a very important area in this kind of thing, because it should be able to withstand heavy gusts and all that. Okay. How drones are used in the military? You have seen that recently. Drones have been used very extensively. Recently, Iran, you know what happened. And reconnaissance and surveillance is being used for last so many decades. It's being used in all parts of the world. But slowly you have seen it is also being used as a weapon system. How to interpret red edge data on UAV remote sensing? Good question. The registered data is something which you use for many applications, including agricultural operations. I won't be able to answer now, but certainly this can be answered later. What is the max speed for Ghatak UCAVs today are essentially designed to be subsonic aircraft. They are not supersonic. And it looks to be that is good enough. So you know what is subsonic. Will engine and propulsion Ghatak will be? Yes, it will be indigenous. Sir, thank you. Anything else? Why can't Meteor missile be integrated with this? It can be done. If Air Force wants, it can be done. Okay. Anything? So I hope I've been able to answer some of your questions. And certainly, I'm happy that such good questions have come. I feel happy because all of you who are asking those questions are extremely knowledgeable, intelligent, and you are asked the right questions. So for a person like me to answer such question, it's good privilege. Thank you. Thank you very much.
Thank you. Thank you so much, sir, for taking up time to answer so many questions. I'm sure our viewers are thrilled right now. I would also request our viewers to please rate us on the quality of the webinar. The poll is being flashed on your screen right now. With this, I would hand over to Colonel Anil Gupta for a few words before we conclude. Over to you, sir. NEG Studio, the mic is mute.
Thank you, Bhumika. Am I audible now? I thank
Yes.
Dr.Kota Harinarayana for a very knowledgeable talk on evolutions of aircraft and various technologies, and especially an in-depth insight of the LCA, that is the Tejas. It was indeed enlightening to know how much efforts and technology has gone into this wonderful world-class aircraft. Thank you, sir.
Thank you.
And the talk also gave us the knowledge of future aircraft programs of India, which definitely will give boost to indigenous capability to achieve India's air superiority. I also thank the participants for a very interesting question and answers session. Over to you, Bhumika.
Thank you, Colonel Gupta. I would also remind my viewers that this session is also available on the Digital India Learning YouTube channel. Please subscribe for future webinars as well. With this, now I would share you the schedule for our next webinar. When you log in to the DefExpo.gov.in website, there is a section here for seminars. Underneath that, please click on webinar, and there is a webinar schedule, webinar guidelines, and webinar links. Now, I would like to remind you that the next webinar would be held on 30th January. That is the last webinar for DefExpo 2020 series. All the registration details, everything is mentioned here. The webinar to be held on Jan 20 has been rescheduled for January 30th. The link would remain the same. I would request you to please click on the link, register from here, and the details would also be available on the social media pages. With this, now I take the opportunity to thank our leadership, without whom this initiative wouldn't have been possible. Dr. Ajay Kumar, Defense Secretary and Secretary Defense Production; Shri Barun Mitra, Special Secretary Defense Production; Dr. Amit Sahai, Joint Secretary Personnel and Coordination; Mr. Abhishek Singh, President and Chief Executive Officer, National E-Governance Division. I express my gratitude to all the above for giving us this encouraging environment to conduct all these webinars. I would also like to thank Captain Nagesh Jain, Brigadier K. Suresh Pillai, and Captain Roy Joseph from Department of Defense Production for providing us all the support. I would also thank the HL team at Bangalore to conduct this webinar from there. Last but not the least, I would thank the NEGD Digital India LMS team for making this webinar a success. Do not forget to log in for our next webinar and the last webinar for the series on 30th January 2020. The winner for the best question would be announced on 30th. With this, now we conclude for today. I hope you had an enjoyable session. Happy learning. Jai Hind.